Hi, Krazifizix Medicine Science Clinic welcomes you to this session. All right, we continue with our paper review. This is Mathematics Paper 1. We're using the Pumalanga 2016 paper, and this is part 2. We have a part 1, which ended on question 3. So we're going to run through. In case you get your hand at this video, please note that it's a part 1 and look for it. Where do we get the video? Go on to www.krazifizix.org.za and click online classes mathematics grade 12. You'd find all the videos. There's maths and there's physics on the site. All right, let's continue quickly here with our next question, which is question number 3. All right, we did question 1 and question 1 to 3. Our next question is question number 4. All right, let's look at question 4 quickly here. Given that g of x is, so we have a function here that includes logarithms. All right, g of x equals to log of base half, and then we have x there. Look at the first question. Determine the equation of the inverse of g. Do not forget that your g of x simply means y value. So I'm going to rewrite this as that. All right, now this is 12. In case you're in grade 11, you can also quickly learn the principle. What we do is this. Because it's an inverse, what do? Anywhere we see y, we inverse it to x, and anywhere we see x, we inverse y. So here I'm going to change it. It's going to become x equals to log half of y. But I must now solve for y. Using our logarithm principles, I'm just going to bring that as a base there. Half x to the power x equals to y. So what is my y? My y is actually 2 negative 1. All right, that goes up x, which is 2 to the power of negative x. And that's my new function. My g inverse is 2 to the power negative x. All right, my g inverse of x. All right, so you have your 2 marks there quickly, and you run away. Let me keep that answer here because I might just need it as we go on. All right, write f in the form of a standard equation there. All right, that is a general formula there. So we have fx plus p. Okay, quickly, how do we do this? Given my f of x as 2x squared minus 4x minus 6. All right, what do I need to do here quickly? Because I need to group this. I'm going to group this, and what do I have? 2x squared minus 2, all right, minus 6. Okay. All right, so what do I have? No, there's an x here. Okay, so we have that. Now, what I want you to learn to do is, I still have my 2 there. X squared minus 2x. Now, the coefficient of x is minus 2. Let's divide that by 2. What are we going to have? Negative 1. But in order to keep my equation the way it is, since I am introducing a negative 1, I will also introduce a positive 1. Now my equation is not changing, right? Okay, and I have what? A negative 6. So do you notice my negative 1, positive 1 still gives me 0. I still have my equation back, and I have my negative 6 out there. All right, in order for me to factorize, I would rearrange. Okay, here I can easily find my factors. All right, I want to see what we're going to do now. We are going to factorize this. If you factorize that, what are you going to have? X minus 1 squared. So the whole of this is giving me x minus 1 squared. By the way, I've got a minus 1 here, right? Now remember that I still have this bracket, okay, which I can just introduce this way. Minus what? 6. So what am I going to have? Let's expand. 2 multiplies this whole bracket, x minus 1 squared. 2 times negative 1, negative 2, and I have my negative 6. So what would this be? 2x minus 1 squared minus what? 8. And that's how we work that out quickly. All right. The graph of f is shifted 2 units to the left. Please, you need to watch that again and rewind. Okay. The graph of x is shifted 2 units to the left. Okay, we need to know that. If you're shifting to the left, you must be adding. All right. When you shift to the left, it's an addition. Okay, because I'm shifting on the x axis. All right. So what am I going to have? This is my new function, right? My new function is 2x minus 1 squared minus 8. Write the equation of the new graph. I'm going to have 2x minus 1 because it's my x value that is shifting, but shifting to the left by 2. Remember, left is positive on the x. So what do we have? 2 minus 1 will give me positive 1 squared minus 8. And that is your equation right there. You get your 2 marks quickly. All right, let's move to the next one. 4.4. Write down the values of x for which log, okay, log x of base 2 is less than or equal to 0. Do you remember what we did with logs there? This 2 is a base here. It must come here and also be a base. So x is less than or equal to 2 to the power 0. And anything to the power 0 would give me what? 1. So if you look at this, it means that my x is less than or equal to what? 1. However, I want you to notice and learn this. Log of a negative number is an error on your calculator. That means my x, whatever my x is, my x cannot be less than 0. You can try this quickly on your calculator and just check. Put any number there. My x cannot be less than 0, which means, because if I leave my answer like this, it goes to infinity. But we are now saying, this is knowledge of logs, it cannot be less than 0. So my answer should be written this way. My x should be between 0 and 1. 1 being inclusive. So that's a knowledge of logarithms that you must quickly learn there. All right. If h is the reflection of g inverse about the x-axis. Okay, hold on. We have our g inverse. I said we would need this again, and here it came. All right. For which values of x will h of x minus f prime of x be equal to 3? Okay, let's find our h of x first. Let's find our h of x first, because they said it is the inverse. All right, well, it's a reflection. When you reflect on the x, the y value changes. So my h of x will now be equal to negative 2. You see, I am reflecting on the x. Keep your x. Okay, our board just went AY. If you are reflecting on the x, keep the value of x. It is the y value that changes. So if you reflect on x, keep x value and change y. If you reflect on y, keep y values and change what? X. So that's my h of x. Now, what is my first derivative? What is my first derivative of x? I'm sure we can derive. It's 4x, all right, minus what? 4. And that's a straight line graph. Now, you would notice something here. If you want to solve, let's try to write this expression now. Negative 2 minus x minus 4x minus 4 must be equal to 3. This is going to be very challenging to solve algebraically. All right, but the easy way is to now, let's check. Can we plot a graph quickly? I want you to see something here. If we were to plot a graph, remember what my h of x is. Let me write my h of x here. What did we get? We said negative 2 minus x. And what is my f prime of x? A straight line graph, 4x minus 4. All right, so let's quickly have a graph here. Let's have a graph quickly. All right. We have that now. Okay, we have that. Can we plot the graph of h of x? It's not very difficult to plot. All you need to do is to quickly find your intercept. If I make x 0, because I'm looking for my y-intercept, then what am I going to have? I'm going to have negative 2, negative 0, right? And that will give me what? Negative 2 to the power 0 there. and that will give me -1. All right, -1. It will give us -1, because what this simply means, okay, somebody's saying, I don't understand what you did. This is simply something as saying -2. Remember, we have this. But if you remember where we came from, all right, if you remember where we came from, I want you to learn to re-express this. Okay, it's something as saying -1 over 2x. So it's -1 over 2 to the power 0. 2 to the power 0 is 1. So you have -1 over 1, -1. I hope that makes sense. -1. So my intercept is -1 there. All right. So what will this graph look like? We must know the shape of our exponential functions. All right. It's a negative y value there. All right. My graph should look like this. Just going to sketch something for us here. All right. My graph should look something like that. All right. And this value is what? -1. Okay. Now, by the way, what is this one here? It's a straight line graph. Again, let's find the intercept. If I make x 0 here, what am I going to have? 4x is 0, right? It becomes 0 times 0 minus 4. What am I going to have? My y value is -4. All right, -4. Let's just have -4 there. -4. Okay. And if my y is 0, because I'm looking for my x now, if my y is 0, 0 equals to 4x minus 4. What am I going to have there? This -4 would come over to that side, and I have 4 equals to what? 4x, and x would be equal to what? 1. So x equals to 1. Are we right? 4x minus 4. Okay. 4x minus 4. So 1. Now let's check this. Let me use this to plot a graph here. Okay, that's my straight line graph. 1. Now the question says we need to find where the difference is equal to 3 units. H of x and the inverse, the first derivative. Now, do you see here the difference? Because we're talking about the y values. The y of this minus the y of this should be equal to what? 3. Look at how many units do I have here? -1 to -4. What do I have here? 3 units. And when do I have this? I have this when x equals to what? 0. For which values of x will the difference be 3? My x will be equal to what? 0. And that's how we work things out there. All right, so what principle am I trying to show you here? Is most of these questions, sometimes some can be solved algebraically, but some will just give you a headache solving algebraically. We need to learn to use our graphs to solve them. Remember, h of x is a y value, and f prime of x is also a y value. The difference between the y values must give you 3 units, and that only happens when x equals to what? 0. If you try to solve it algebraically, it's going to throw you around and keep throwing you around, and you don't have time in an exam to do that. All right, so learn to use the graphs. Let's run to question 5 quickly. Okay, financial maths here. Read the advertisement carefully. The question below refers to the advertisement that we have here. All right. Bank with Reformed Bank, 8.75% interest compounded monthly. Okay. When you hear compounded monthly, automatically know that the interest will be divided by 12 because the 12 months. So it will be compounded or calculated 12 times in a year. How many months will it take an investment to double if the money invested in the account as advertised above? All right. Now, this is talking about appreciation. And what's my formula? Quickly, you must know that the investment is doubling, it's increasing. A equals to P 1 plus I N. But the issue here is we do not have the value. So if my principal value is P, to double the amount, what am I going to have? 2P, which means 2P will be my A. So we just come in here to say 2P equals to A, 1 plus, now what's my interest? My interest is 8.75%. You must divide that quickly. That will give you 0.0875. All right. So that will give you 0.08. But this one is annually. What do we do? We're talking about monthly. Divide by 12. And what will my N be? They said how many months? That's what we're looking for. N. Okay. By the way, this is P. Now what you notice, you can divide both sides by P. So what are you left with? You're left with 2 equals to, all right? Now, I want us to learn not to round off in, when we do our financial maths calculation. The more you round off, the more problems you're going to run into. Here, what do we need to do? We introduce our logs. All right, I need you to learn the logs. I've heard a lot of learners saying, I don't know how to use logs. This whole value becomes the base of your log. So I'm going to have log 2, and this value becomes my base. 1 plus 0.0875 over what? 12. That's my base, and that should be equal to n. All right, and all you need to do is to quickly run to your calculator. All right, run to your calculator and just do exactly that. What are you going to have? Okay, log, see the log I'm using there? All right, it's 1 plus 0.0875. All right, close the bracket there. But remember, this needs to be divided by, we need to divide that. So I'm just writing exactly that, 0.875 divided by what? 12. And what do I have here on the other side? What do I have? I've got a 2. What's my answer? 95.406. All right, so I hope you follow what I just did there. N equals to what? 95.4063, 0.63387. And that we need to round off. It gives us 95.41 months. All right, so this is using your logs. So remember the whole base there. What, something else we could do is, since we have 2 equals to 1 plus 0.0875 over 12, and with that as n, is to take the log of both sides. All right, so I'm going to have take log 10 of both sides. So I'm going to have that, and I will have this. So it's log 10, 1 plus 0.0875 divided by 12. I still have this there. And the rule of log is that this exponent n comes down here. So I'm going to have what? N log 1 plus 0.0875 over 12. All right, and this is log what? 2. So what would I say? Divide both sides by log of that big number there. So n will be equal to log 2 over log 1 plus 0.0875 divided by 12. All right, if you check your calculator and put this in your calculator, we should be having the same answer. Let's just quickly see how to put that. I now use this log because it's natural log, log base 10, log 2, and what do I have? Again, natural log. You need to rewind the video and see the difference between the logs that I used. What do I need here? I need 1 plus, then I need my division, 0.0875 divided by what? 12. And what's my answer going to be? My answer, 95.406, which is 95.41. All right, so I need you to learn both ways, 95.41 months. It's both, you need to learn both ways quickly in how to deal with your logs. All right, and you get yourself 4 marks. Let's move to the next question. John, the owner of a mine, has just bought a new excavator for 2.4 million. All right. He has decided to replace the excavator in 5 years. In 5 years' time, when its trade-in value will be 800,000. Guys, you need to read the story here. This is the literacy. All right. So he bought a new excavator for 2.4 million. Plans to resell this excavator, all right, to replace rather. But when replacing, he's going to sell the old one and get an amount of 800,000. All right. The replacement cost of the excavator is expected to increase by 7% per annum, compounded semi-annually. Now, what does your semi-annual mean? It means it's compounded twice. Okay. John wants to pay cash for the new excavator after trading in his current excavator. I hope that makes sense. Look, let's quickly explain this. John bought for 2.4 million. All right, he bought this and is going to resell, trade this in. All right, but the new value of this would only be 800 what thousand, and that will be in 5 years' time. So this is depreciate. It's a depreciation. All right, it's depreciating there. All right, so the question now says John wants to pay cash for the new excavator. How much will he need to pay? All right, I wanted to notice something, that these 2.4 million that John used in buying, the worth of the machine is depreciating to give us what? 800,000. However, the price of a new machine is actually appreciating. It's going up. Remember, John bought this for 2.4 million, which is increasing by 7% compounded semi-annually. But the worth of the machine, it's a second-hand machine, after 5 years will be 800,000. So what is the worth of a new machine in the next 5 years? It's an appreciation formula we use here. All right, it's inflation, it's increasing. So our A is P. Look, another way is to say it's a future value. This actually represents a future value, because we're saying what is the future value of 2.4 million in 5 years if it is having an increase of 7% compounded semi-annually. So what's my current value? I'm looking for A. What's my current value? It's 2.4 million. All right, you need to check the zeros. Okay, and then what do I have? 1 plus 7% is 0.07, compounded how many times? Semi-annually, twice a year. So it's compounded twice a year in 5 years. So what am I going to have there? 2 multiplied by 5. That gives me 10. So what is the worth of this machine in the next 5 years? 2, 4, 1, 2, 1, 2, 3. Please be careful of the zeros. All right. And then what do you have? You open a bracket. 1 plus, I have that, 0.07 over 2. And then we close the bracket, exponent 10. What's my answer? 3385437, which means it's now increasing. Instead of 2.4 million, what is my value? It's 3,385,437. 3,385,437,03. This is what the machine would cost in the next 5 years. However, John has this machine, and this machine is now worth 800,000. How much will John pay? John will pay, amount to pay. It will be the worth of the machine then. Okay, let's put rands there. Respect money. All right. Minus the 800,000 that he has now, that he would have in 5 years. I hope that makes sense, because he's selling it's like selling the machine and getting 800,000, goes to buy and they tell him, look, the price is now 3.385. So he gives them the 800,000. So this is the amount that he needs to pay. And what do? We go back to our calculator and say minus what? 800 and then 3 zeros. All right, please be careful again. It must not be more. Once you place more zeros, it's 5 zeros. 1, 2, 3, 4, 5. And what's my answer? John would need to pay 2,585,437. That's what John is paying. So he's paying 2,585,437 and 3 cents. That's what John would pay. All right, because the new cost of the machine is 3 million plus. 1 month after purchasing the present excavator. So look, in financial maths, you must always ask yourself, am I looking for a future value or I'm looking for a present value? 1 month after purchasing the present excavator, John deposited X rand in an account. Now, we're talking about sinking fund. Let me quickly explain. So John is aware that his machine will cost 800,000 in 5 years. John knows that the new machine will cost what, 3.385. Now John needs to save 2,585,000. This is what you call your sinking fund. What John needs to save. And to save this, John needs to deposit money in the account every month. Whatever he deposits is called X. Now, so he's going to deposit X. I want to just do this before we calculate. John is depositing X monthly. So that in the future he has saved his sinking fund. I hope that makes sense. John needs this amount in 5 years' time. So what does he do? He starts saving now so that in the future, 5 years, he has this amount. That's the whole analogy of sinking funds. All right, sinking fund is a future value. 1 month after purchasing the present excavator, let's try to run through the question. John deposited X rand into an account that pays an interest, all right, per annum, 16% per annum compounded monthly. He continues to deposit the same amount. Guys, this is what makes this formula different. This is also a future value formula, but we use this for only one deposit. Once I have a continuous monthly deposit, I need to use my FV, which is what? X. All right, you must know the formula. X 1 plus I. Do you see my formula coming in there? All right, do you see that? That's my future value formula there. All right, minus 1 over interest. Okay, so he continues to deposit at the end of each month for a total of what? 60 months. Remember, this is compounded what? Monthly. After 5 years, he has the exact amount that is needed to purchase, which is what we got here. Calculate the value of X. Now he has the amount. Remember, my sinking value, my sinking fund is a future value from now. So what do I have? I have 2,585,437,03. I'm looking for X. Okay, and what do I have? 1 plus, what is my interest rate, by the way? 16%. 0.6 compounded what? Monthly, divided by 12. For how many months? 60 months. All right, minus 1 over, what's my interest? 0.16 divided by what? 12. Okay, I want you to learn mathematically that this X is actually multiplying this whole thing. So what do? Divide both sides by this whole factor. All right, divide both sides by that. Now let's go work with our calculator. All right, but let's make it easy for everyone. 2,585,437,03 equals to X. What will this whole thing give me? Let's run to our calculator quickly. All right, let's run to our calculator. You must learn to respect the brackets. All right? Learn to respect the bracket. So what do I have? I have 1 plus, what do I have? 0, 0.16. All right? 0, 0.16 divided by what? 12. And then what do we have? We have what? So the, no. We have, it's an exponent there. 60 minus what? 1. 60 minus, oh, we should have actually put, but it's fine. It's still okay. We should have used the double division, but it's all right. There's no problem here. So we get our answer here, 1 plus, I hope that makes sense. And that gives us that value. But this answer must now be divided by what? 0, 0.16 over what? Over 12. So the whole answer there gives me 91,035. 91,035. All right? 91,035. So what do I do? Divide both sides. You would see what I'm going to do here now. I'm writing 91,035 just because I don't want to write the long answer, but I'm going to use that same long answer to do what I have to do. So I'm going to now say, remember my 91,035 is just a short part of the answer. I'm not going to say 2,585,437 rand 3 cents, cents, divided by my answer. What's my answer? 28,400 rand 31 cents. That is what John needs to save every month. X is what? 28,431. That's what John saves every single month. All right, that's how. So remember, your sinking fund is a future value. John's brother Michael wants to invest in the mine 3 years after John has bought the mine. They agree that Michael pays the rest of the monthly installment in a lump sum. All right, check something. 3 years after. 3 years after. Okay. They agree that Michael pays the rest of the monthly installment at once. That's what this means. All right, a balloon payment. What is the amount that Michael has to pay in order to still buy the new excavator in 5 years' time? In 5 years' time. All right, hold on. We're talking about 3 months. Remember, it was 60 months, 5 years. But now we're talking about what? They have made payment for what? 3 years. All right, and 3 years would give you what? 3 times 12 would give you what? 36. So they have made payments for 36 months. They are owing for how many months? 24 months. Guys, once you think about owing, you use your PV now. The amount that is owed becomes a PV. All right. So let's calculate. Our PV formula will be equal to X. All right. 1 minus 1 plus I negative N over I. Now, what's my PV? I'm looking for what they owe if they still pay. Remember, they are still paying this amount, right? 1 minus 1 plus, it is still 16%, right? It is still 16% over 12. But for how many months are they left to pay? 24. I hope you understand my 24. Because they paid for 36 over 0,16 divided by 12. And then you go to your calculator and let's get our answer. All right, let's get an answer quickly. Okay, what do I have here? I have 28400,31. And what do I have? I have a bracket. I have 1 minus. I need another bracket. Okay, and I have 1 plus. I need my division there. 0,16 divided by what? 12. And what do I have? We close the bracket, but remember now it's an exponential value of negative what? 24. Be mindful when you use your calculator, the number of brackets must be the same. If you open two brackets on the left, you must close with two brackets. And what do I have here? I need what? 0.16 over what? Over 12. Okay, what's my answer? 580034. All right, that is 580,034. So what they are owing after 36 months, 3 years, would be 500 and what? 80,000 and 34, what? 84 cents. Guys, this is how we work with financial maths. This is the basic financial maths questions. All right, quickly, we run to question number 6. First derivative. Given that my f of x equals to what? X squared minus 3x, derived using first principle. This is what I always say. In one corner of your page, know what your answer would be. All right? 2x, if you derive this directly, 2x minus 3. That's what I should get. All right. What is my formula? My formula is, okay, before you start, since you know the formula, I always like to do this separately so that every learner gets it. What is my fx plus h? It means anywhere you see x, write x plus h. So what am I going to have? X plus h there, squared, minus 3x plus what? I hope that makes sense. Anywhere I see x, I replace, because I'm replacing this, I must replace this, I must replace that. Can we expand this? All right, this will give me what? X squared plus 2xh plus what? H squared minus 3x minus 3h. All right, now I can run to my formula. Limit as h tends to what? 0. You must always write that. You must always write that. Let's start like this. F prime of x equals to limit as h tends to 0. All right. What's my formula? Fx plus h minus f of x over h. That's my original formula. So can we now replace that? Because of space, I'm just going to remove that one and keep writing my limit. That's mathematical. What is my fx plus h? X squared plus 2xh plus h squared minus 3x minus 3h minus. Now, when you remember in the first video, we even said when you put in a minus, please learn to open a bracket. X squared minus 3x. Everything divided by what? H. Okay, what do we do? Equals to limit as h tends to 0. If we open this bracket, all right, x squared, this is going to be minus x squared. I don't want to waste time. Now, minus times minus 3x will give me positive 3x, right? So positive 3x minus 3x. What do I have left? 2xh plus h squared minus 3h over what? H. What do? We factorize now. H, come on, 2x plus h minus 3 over h. That divides that. Now, this is where you now replace your h with 0. And once you replace your h with 0, you no longer write limit. So what are you going to have? 2x plus 0 minus 3. What's my answer? 2x minus 3. Let's scroll up quickly and check what we said we should get. 2x minus 3. You have your 5 marks there quickly. All right, so first principles. If I have enough time after this video, I'll do some other questions. Look at this. Find the derivative. When you say dy dx, find this. All right, find this. What is my y? X plus 1, 2 minus 3x. Advisably, always solve before you derive. Can we expand that bracket by using our FOIL? All right, by using our FOIL. Y will be equal to x times 2 would give me what? 2x. X times negative 3x will give me negative 3x squared. 1 times 2 would give me positive 2. and that will give me negative what? 3x. Okay, we can combine here quickly. All right, what am I going to have? Negative 3x squared. 2 minus 3 would give me minus x plus 2. Now I derive dy over dx. I'm sure we know how to derive. This 2 comes down to multiply this 3. What do you have? Negative 6x, because I subtract 1 from the exponent. And if I derive negative x, I have what? 1. All right. That's how we deal with that. 6.2.2. Derive if y equals to negative 2. Don't let all of this scare you. Try to solve it. What will this be? Y equals to negative 2x to the power half plus x minus 1. Okay, we can just quickly bring this. This is x to the power half. It becomes negative half because it is the exponent there. All right. So what do we have here now? We are going to have our dy dx will be equal to, all right, so when we derive, what are we going to have? My half would come down to multiply my negative 2. So half times negative 2 would be negative 1, which gives me negative x. Then I subtract half minus 1 would give me negative what? Half plus, remember there's a 1 here. That 1 comes down, it gives me 1. Then I subtract 1 minus 1, x to the power 0 would give me 1. That's how we get our 1 there. Negative half times negative would give me what? Positive 1 over 2x. Now negative half minus 1 would give me negative 3 over 2. And that is my answer. You can actually leave it like that, or if they want you to have it as powers of positive x, you can just rewrite it. This will be negative 1 over x half plus 1 plus 1 over 2x 3 over 2. All right, and you are done with your questions there. Question number 7. All right. Sketched below is the graph of g of x. We have the function there, and this examiner is so kind to have helped us to solve this here. All right, and given f of x, a straight line to x plus c. A and D are the x-intercepts of g. OB is 6 units. A and C are the turning points of g. Okay, so we have this. The first question says write down the coordinates of A and D. Now this is very, very straightforward because the examiner actually already helped us a lot here by giving us the value, by giving us this function, rewriting this function as g of x is x plus 2 squared x minus 3. Now do you notice A and D are x-intercept? All right, if I'm looking for x-intercept, what do I say? My y value must be equal to 0. So 0 equals to x plus 2 squared x minus 3. So it is either x plus 2 squared equals to 0 or x minus 3 equals to 0. X, okay, x plus 2 now equals to 0. All right, if you square both sides. So x equals to minus 2. But I'm going to have two values there. Why am I having two values? The graph actually turns at that point A. So we have two values there. So it's negative 2. Can you see the square there? Negative 2 and it's twice. Or x equals to what? 3. So what do I have at A? My x is negative 2 and my y is 0. And at D, my x is 3 and my y is what? 0. All right, write down the coordinate of C. What do you notice about C? C here is my turning point, just like A. How do you get the turning point? Because we are told A and C are turning point. The first derivative must be equal to what? 0. So what's my, okay, here we have g of x. So my first derivative of the function should be equal to 0. But what is g of x? G of x equals to x cubed. It is easier to do this. to derive a linear. All right, so g prime of x will be equal to what? 3x squared plus 2x minus 8. Now this must be equal to 0. Okay, can we factorize quickly? If we need to factorize this, going back to question 1, my product is negative what? 24. All right, and my sum is equal to 2. What are the things that I will multiply to give me 24? That will give me 2, 6 and 4. All right, since I want a positive 2, I'm going to say 6 minus 2. So I have that. Do you see that already done there? 3x squared plus 6x minus 4x minus 8 equals to 0. Now we group this and quickly factorize. 3x, x plus 2 minus 4, x plus 2 equals to what? 0. So x plus 2, 3x minus 4 equals to 0. X equals to negative 2, or x equals to 4 over 3. Do you remember my negative 2? Point A, another turning point. But I'm looking for point what? C, which is 4 over 3. But how do I get my y value? Substitute x in the original what? Equation. So I have g of x equals to, it's going to be 4 over 3 cubed plus 4 over 3 squared minus 8 times 4 over 3 minus what? 12. All right, so if you put that in your calculator, you get your y value very, very easily. So let's put that in our calculator quickly. We open a bracket there. All right, I have that. Okay, what do I have in this bracket? It is 4 over 3. And what do I have exponent there? Exponent is 3. All right, plus, what do I have again? I have another bracket. It is important to use your bracket. And what do I have there? Squared minus 8 times, again, what do I have? 4. Remember, I'm just using my value there. And what do I have? Minus 12. What's my y value? Okay, my y value should be negative. All right, let's see. Yes, correct. Negative. Negative 500 over 27. Negative 500 over 27. You see, it's negative here because on my y it's negative. So what's my coordinate of C? C is 4 over 3 and negative 500 over what? 27. That is the coordinate of C. All right, write down the equation of F. What do you notice? F is a straight line. F is a straight line, 2x plus C. But what do you notice here? F actually cuts through the x-axis, all right, at D, and cuts through the y at B. But do I know a point? Let's go check quickly. F of x equals to what? 2x plus C. But I do know the value of D. Remember, we got the value of D. D is what? 3 and 0. Our x is 3. So all I need to do, remember, my y is 2x plus C. What is my y value? 0. What's my x? 3. So what is C? I should be getting a negative answer because it's there. All right, so my C, which is my y-intercept, is negative 6. So what's my equation? F of x equals to what? 2x minus 6. And then you get your, it's 1 mark because we expect everyone to be able to get that. Calculate the x value of the point of inflection of G. Now, when they talk about point of inflection, you actually derive twice. All right. But since I'm dealing with G, I'm going to just do that. Remember what was our first derivative? We can quickly get our first derivative. What was our first derivative? All right, we just derive quickly. All right, let's derive again very, very fast. Okay, my first derivative, just in case somebody got lost along the way, is 3x squared plus 2x minus 8. Now what is my second derivative? My second derivative will be 6x, all right, plus 2. And this now, 6x plus 2 must be equal to what? 0. 6x equals to negative 2. X equals to negative, which is equal to negative 1 over 3. That's my point of inflection. All right, negative 1 over 3. Another way you can do that is to say negative b over 3a, point of inflection. Remember, this is my a is 1, all right? My b is also 1. My c is what? Negative 8. And my d is what? Negative 12, because we're saying ax cubed plus bx squared plus cx plus d. So negative, what's my b? 1 over 3. What is my a? My a is 1. All right, negative 1 over 3. Same answer as that, point of inflection. All right, use the graph to determine the values of t for which g of x equals to t will have only one root. All right, let me just quickly explain this now. Nature of roots again will have only one root. Here is my graph. That it will have one root means it should cut through the x-axis once. Now if you bring this line down, I'm going to use a blue thing. Look at my x-axis. I'm having 3 distinct roots there. 3 distinct. All right, 3 distinct. Until it gets to this point, I want you to see until it gets to the turning point. Okay. Anywhere below the turning point, this graph would cut once. One root, one real root. Anywhere above this point as well, this graph will cut once. One real root. Okay, what is my x value here? My x value there is 3. All right, so x must be greater than 3. And what is my value here? What is my value here? I'm looking at my y value here. All right, what is my y value there? My y, what's my turning point? We got our turning point earlier on. Okay, if you scroll back, you'd get your turning point. Our turning point was 4 over 3 into negative 500. All right, so what will my answer now be? Now, x is 3 here, y is what? 0. It means at anywhere above this. Remember we said g of x equals to t. So basically we are looking for y values. So what should we say? My y must be greater, or since I'm looking for t, my t must be greater than 0, or my t must be less than my turning point. Let's go back to the graph again quickly. Let's just go back to the graph. My t must be less than here. Anywhere here, anywhere below gives me one cut. Anywhere above my other turning point gives me. So basically we are dealing with the y values of our turning points. All right, for which values of x is f of x? Okay, let's write this function quickly. For which value will f of x, I think I'm going to need this. Let me write it here. F of x multiplied by what? The g prime of x less than what? 0. Okay, quickly. Where is my f of x? It's a straight line. For this to be less than 0, it means the product must be negative, which means I must get a negative here and a positive here. A positive here and a negative here. Once I get that, I get a negative answer, which gives me less than what? 0. All right, so for which values will the product be less than 0? You know, to make it easy for you, what we can easily do, we know our f of x, right? And our g prime of x is a parabolic function. What is our g prime of x again? We got what? 3x squared. All right, we got 3x squared plus what? 2x minus 8. And when we did this earlier on, I remember it was x equals to 4 over 3 or x equals to what? Negative 2. All right. I want to do something here for you. X equals to negative 2. It's a parabolic what? Function. No, it's 3x squared. Now, it's positive, which means it's a smiley face. But what are my x values? My x value is 4 over 3, which is my turning point. All right? And x equals to negative what? 2, another turning point. So my graph actually comes this way. My graph actually looks like that. Now, for which values will the product of these two graphs, okay, now I'm looking at, let's make our life easy. I'm going to have to cut this page. I'm going to have to cut this page. Okay, I need a new page just to make sure that we get this principle correctly. I want us to get this principle correctly. All right, it's the last question. So now what do we have here? We have this and we have this. I have got a straight line graph because the question talks about f of x. All right, f of x. And remember we said we have a graph like that, right? Which is this. All right, and it cuts just before that. Okay, let me extend the graph a little bit so that we are able to see correctly. We have that, and we have this, where this is negative 2, and this is 4 over 3, and here what we have 3. Now, I want f of x and g of x. The product should give me less than 0, negative value. So we said f of x multiplied by g prime of x. This is my g prime of x, and this is my f of x. One must be positive and the other one must be negative. All right. So now, but if you check here on this x value, check your cardinal point at this value, because this graph continues. Both of them are positive, so this side is out. What if I come in between here, from here to here? What you notice, my f of x here is negative, but between here and here, my g prime of x is positive. I need that value there. All right, look at this. From here, both are negative, so it's wrong again. Are you there? Look at 0. They give me 0 there. All right. On the side, both of them again, I'm looking at my cardinal point. Both of them are negative. Again, it's wrong. But what do you see here? After negative 2, what do I have? I've got a positive value and I've got a negative value. So where are my answers? I have that there, and I also have positive and negative. So what will my answer be? What will my answer be? I'm going to have two answers. X lies between 4 over 3 and 3. So I'm going to say x lies between 3 and 4 over 3, or x is less than negative 2. And that's how we deal with that question. That's how we deal with the question. Perfect. Perfectly done there. All right, question number 8. In the diagram, ABC is an equilateral triangle whose sides have length 3 units. DEFG is a rectangle inside the triangle as indicated. D lies on AB, you can see the diagram there, and G lies on AC, EF lies on BC, BF is equal to FC, and that equals to X. Show that DE is X tan 60. All right, they told us it's an equilateral triangle. Automatically, what do we know? Angles are what? 60. And then I have this, which is what? DE. And this is what? X. All right. So this side becomes what? Opposite. This side becomes what? Hypotenuse. And this is my adjacent. What am I looking for? DE. I am looking for opposite. But by the way, I have my adjacent. Opposite and adjacent. Tan 60 equals to opposite over what? Adjacent. So what do we have? Tan 60, what's my opposite? DE. What's my adjacent? X. DE equals to X tan 60. And that's done. 3 marks there. Prove that the area of the rectangle is given by A. We need to prove this. We need to prove the area of the rectangle. Okay. What do we need to do here? Guys, we are told that this is 3 units. So this is going to be 3 minus 2x. How did I get my 3 minus 2x? This is x plus this will give me 3. All right. So area of a rectangle is length. So area is length times breadth, which is DE multiplied by what? EF. By the way, what's our DE? Our DE is x tan 60 multiplied by what's our EF? 3 minus 2x. All right. What is tan 60? If you check your calculator, tan 60 is root 3. So x root 3 multiplied by 3 minus what? 2x. And that's what we are trying to prove there. All right. Okay. Root 3 x 3 minus 2x. Done. Calculate the maximum area. Guys, when you hear the word maximum and minimum, you need to derive. So this is an application of our derivative. So a equals to the square root of 3 x 3 minus what? 2x. Now let's derive this with respect to x, our first derivative. Okay, before we derive, we need to solve. Let's rewrite this as a simple linear expression. All right. What we are actually saying, let me do this so that it's easy for us to solve. We multiply through. All right, we multiply through. This will give me 3x root 3 minus 2x squared root 3. That's my a. All right, we multiply through first. Always make sure you get a linear expression. Now what do? We now derive. Okay, we now what? Derive. How do we then derive this? Remember, you are only deriving with respect to x. Now there's a 1 here. 1 times 3 would give me what? 3. Then x to the power 0 would give me 1. So I'm left with 3 here. All right. I'm left with 3 root 3 minus, what am I going to have here? 2 times 2, what am I going to have? 4 x 2 minus 1 root 3. Okay, so what do we do here quickly? What do we do here? Oh, by the way, yeah, what do we do here? Now, what do we do here? We equate to 0 because it's like your turning point. Your turning point has maximum and minimum. So 3 root 3 minus 4x root 3 equals to 0. All right, 4x root 3, or we can just say 3 root 3 equals to 4x root 3. What do we do? Divide both sides by square root of what? 3. What do I have? 4x equals to 3. What is x? 3 over 4. That's my x, but the question says the area. So I go back and into my area formula. What's my area formula? Now I know my x is 3 over 4. Area equals to root 3 multiplied by what? 3 over 4 into bracket 3 minus 2, because that's my area formula. All right, that's what we're given as the area formula. So what do we do now? We can actually solve all of this. All right, or if this confuses you, you can use your expression. You remember we had to solve this earlier on. Let's go back again to our area. All right, we solve this by saying 3x root 3 minus 2x squared root 3. 3x root 3 minus 2x squared root 3. We did this. All right, and this gives you what? 3 multiplied by 3 over 4 root 3 minus 2 3 over 4 squared root 3. Whichever way, you would get the same answer. All right, let's quickly see. Let's see. I have a root 3 here. All right, root 3 multiplied by 3 over 4. I have that bracket there, and I have another bracket. What do I have? 3 minus 2 multiplied by 3 over 4. Now remember, the number of brackets open must be equal to the number of brackets closed. I need to close this bracket again. And what do I have? 9 root 3 over 8 units. So either use this or this, you get the same answer. What is my area? Area is 9 root 3 over 8 units squared. All right, you can leave it like this, or you can express it in fractions or decimals if you want. 1,95. 1,95, because it's area, we say it's units squared, or squared what? Unit. And then we are done with that. Awesome. Question 9, probability. If probability of A is 3 over 8 and probability of B is 1 over 4, calculate probability of A or B if A and B are mutually exclusive events. You need to know how to deal with exclusive and independent events. Now, what's my formula? Probability of A or B equals to probability of A, or B plus probability of minus probability of A and B. Now, what is the probability of A? 3 over 8. Probability of B? 1 over 4. Exclusive means they have no point of exclusive. There's nothing inclusive there. Minus 0. All right. If you use your calculator here, you are going to get 5 over 8. Quickly. 5 over 8. All right, that you need to be able to learn using your NBT if you're preparing for NBT. Now, if they are independent events, we are still looking for A or B. If they are independent events, it's probability of A plus probability of B minus probability of A and what? B. Now, what's probability of A? Okay, this, now I want you to see the difference between exclusive. Independent event means they depend, all right, on each other. So we have got probability of A plus probability of B minus probability of A times probability of B, because it's and depends. So what is A? 3 over 8 plus 1 over 4 minus 3 over 8 times 1 over 4. All right, what will our answer be here? Quickly, let's check our calculator. 3 over 8 plus 1 over 4, all right, minus 3 over 8 and times 1 over 4. 17 over 32. 17 over 32. And you're done. So please get exclusive and independent events very well. The probability of getting the first answer in a quiz is 0,6. 0,6, correct. All right. If the first answer is correct, the probability of getting the second answer correct rises to 0,7. However, if the first answer is incorrect, the probability of getting the second answer is only 0,4. Determine the probability of getting the second answer correct. Okay, you must know which method to use. We're talking about two events here. All right, if one, then two. Automatically, you should talk about your tree diagram. So I am going to draw a tree diagram of correct. Okay, I'm going to need space, correct, and wrong. First answer. Probability of getting the correct first answer is what? 0,6. Remember, your total probability should be 1. So this is 0,4. Second answer, correct or wrong? Correct or wrong? Now, it says if the first answer is correct, the probability of getting the second answer correct is 0,7. So second answer correct, 0,7. Automatically, this becomes 0,3. However, if the first answer is incorrect, which is wrong, the probability of getting the second answer correct, I'm dealing with correct, is 0,4. So this is 0,4 and 0, what? 6. What is the probability of getting the second answer correct? Let's quickly check this. This is first answer correct, second correct, first correct, second wrong, first wrong, second correct. Both are wrong. What am I looking for? Probability of getting the second answer correct. It is either this or this. So it is either probability of both correct or, okay, probability of both correct or the first one wrong and the second one correct, which should now be equal to probability of both correct plus probability of what? All right, which we can expand here. Probability of the first one correct multiplied by the probability of, because it is and, get the first one correct and the second one correct, plus the probability of the first one wrong and the probability of the second one correct. So the first one correct is 0,6. All right, second one correct is 0 because it said it rises to 0,7 plus first one wrong is 0,4 and the second one correct, what our second one correct, is 0,4 as well. All right, now if you use your calculator quickly here, let's quickly run through our calculator as we round off this session. All right, plus, remember it's 0,7 plus 0,4 squared. That will give me what? 0,58, and that's my correct answer. All right, so that's how you work things out. Okay, 3 married couples, Mr. and Mrs. Small, Mr. and Mrs. Beaver, and Mr. and Mrs. Koza are seated on a bench. How many ways can the people be arranged? How many people do we have? We have 6 couples. 3 couples, 6 people. And they can be seated anyhow. All right, so what do I have? I have 6 people for 6 spots. Automatically we just say 6 factorial, and that should be equal to 6 factorial should be equal to 720 ways. 720 ways. All right, now calculate the probability that Mr. and Mrs. Koza are seated next to each other on the bench. All right, hold on. It means Kozas must be seated next to each other. The first thing we need to do is this. Kozas must be seated as a group. All right, and they can be seated either Mr. or Mrs. in 2 ways. Either the man sits first or the woman sits, and like that. That one automatically is factorial. Now what we do is this. How many units do we now have? Remember, these guys are single seated. 1, 2, 3, 4, and this one 5. So it becomes over that. All right, 2 factorial times 5 what? Factorial. But remember now that we're looking for probability. It must be over 6 what? Factorial. Let's go check our answer quickly. All right, it is 2 factorial multiplied by what? 5 factorial over 6 what? Factorial. And what's my answer? 1 over 3. Right, my answer is 1 over 3. And that's how we work it out. So when they are grouped together, you take them as 1. So I have 1, 2, 3, 4, 5. But this one can interchange. That's why we first have 2 factorial. And then we have 5 factorial over total. And we have what? Total is what? 6 factorial. And that's how we work this out. All right. And you have 150 marks there. This is 150. All right. In all. Thank you for joining us in this session. We hope you have benefited a lot. All right, there should be another maths video that you can also work with. This is Krazifizix. All right, this is another production of Krazifizix, and here we're looking at maths. Please remember to check our webpage. All right, krazifizix.org.za. You'll be able to get all information you need. If there's any information you need, there's a front page there. Give us a review or send us an email and we'll be able to get back to you. Our book is, getting set for the market for next year, 2018 or 2019. All right, it will be out there in the market. It's called the Mathematics Spectrum. We look at maths from grade 10 to grade 12 in one book because maths is progressive. Thank you for being part of this session. And this is Bishop signing out. 0817442103. Thank you. Keep well. See you in the next video.